So I'll try and keep it as short as possible. Okay, so before we get going, I was going to start with a quiz. So there's prizes in this quiz. I've got some books here. So points mean prizes. So this question is, this generation has altered the composition of the atmosphere on a global scale through a steady increase in carbon dioxide from the burning of fossil fuels. Which US president said that? So hands up if you know the answer. Yes, at the back.
Johnson.
Yes, it is Johnson. Well done. That was Johnson, and he said it back in 1965 in a special message to Congress on the conservation and restoration of natural beauty. So, Christian, could you take that up? Right. Next one. So, who knows those scientists? Who wrote the paper on the influence of carbonic acid in the air upon the temperature of the ground? Does anybody know who A, B, and C are? So A is a bloke named Svante Arrhenius. He was a Swedish chemist who won the Nobel Prize. B is is an engineer and an amateur meteorologist called Guy Callender. And C is a US scientist called Roger Revelle who studied oceanography. So was it A, B, or C? Hands up, sorry. Yes. Yes, it was A. It's Svante Arrhenius. And he wrote that paper. Here it is. This is the cover of the paper. He wrote it back in 1896. And he did this calculation by hand. And he was apparently suffering depression from divorce with his wife. And he sat down and gave himself a huge problem to do, which was to calculate how the temperature of the planet would change if you changed carbonic acid in the atmosphere, which we now call carbon dioxide. He came up with a figure that he calculated by pen and paper, which is pretty close to the figure that we now get when we carry out our huge supercomputer model simulations. Okay, last question. What percentage of practicing climate scientists agree that humans are causing global warming? Yes, go ahead. It's not 100 quite. 99.9? No. No. Who said 97? Well done. There you go. Thanks, Christian. Okay. Yeah, so it's 97 out of 100 when polled. And there's different ways of doing this. So you can ask climate scientists directly in terms of an opinion survey. But the other way that people have done it is to go through abstracts of all the scientific papers published on climate change and assess whether or not they make an attribution statement in that paper and say, does climate change is it caused by humans? And if you do that, then pretty much 97 out of 100 papers say that humans cause climate change. So, my talk, the brutal logic of climate change. I won't explain why it's called that just yet, but hopefully it will become apparent as we go through. As Christian said, I studied here. I see myself as a scientist by training. I went and studied how climate change is impacting on ecosystems in the Arctic for my postdoc, and it's something that I am very intellectually interested in. But although much of this talk is me as a scientist trying to convey scientific information to the audience, it's also a talk where I'm trying to get you to do something. So I'm speaking here as an advocate. I'm very open about that. I have values. I'm a human being, and some of those values are informed by what I've learnt, and therefore, where I'm speaking about facts, they are, to the best of my opinion, a scientific fact, and where I'm talking about my opinions and values, then obviously you have to understand that in that sense. I think scientists need to be able to do that. I think scientists should do that and should do that more often. Okay, so another last poll. On a scale of 1 to 5, how concerned would you say that you were about climate change? I'm going to ask you for a show of hands. So 1, not bothered. 2, mildly concerned. 3, concerned. 4, very concerned. And 5, alarmed. Okay, so there's more people who are saying they're alarmed than normally I would expect in an audience, which is I guess a good thing, because that is the right answer. You should be very alarmed, and I'll explain why that is. But firstly, the very basics of climate science. I'm not going to go into this in a lot of detail, because I'm sure you already know it. You got the sun gives out shortwave radiation. That radiation arrives at the Earth and warms the temperature of the planet. Some of that would then be lost again to space because of outgoing shortwave radiation, but atmospheric gases that we call greenhouse gases absorb some of that and keep that heat around the planet and increase the temperature of the planet. We know that as the greenhouse effect. One of those gases is carbon dioxide. We've been putting out lots of carbon dioxide into the atmosphere as a result of burning fossil fuels, oil, coal, and gas. And as a result, the temperature of the planet is going up. Simple. We know, looking at historical records, that temperatures are very closely related to the level of CO2 in the atmosphere. We get this data from drilling ice cores in Greenland and Antarctica, where we can look at the air from really long ago that's been trapped in the snow layers, which are then frozen into ice. And that can tell us what the concentration of CO2 was in the past. And likewise, we can analyze the water molecules to tell us what the temperature was in the past as well. And we can go back very, very long periods of time. So this graph shows us the last 400,000 years. And what we see is that there's a cycle, which we call the Ice Age cycle. And those cycles typically last about 100,000 years. And you can see just how closely related both the temperature and carbon dioxide levels are to each other. The other two really important things to pick out here is at the end of the red line over here, you can see that there's a stable period where it just kind of wiggles around a little bit. That's the period we know as the Holocene. It's the last 10,000 years or so, and basically the whole of human civilization has taken place during that period. So we're talking about the creation of agriculture, settlement around the world, the Roman Empire, the Egyptians, all of it. That's in that tiny bit at the end of the timeline there. The other thing to notice is if you follow the blue line to the end, you'll see it suddenly spike up. And that's the result of us burning fossil fuels and putting it into the atmosphere. And as a result of that, temperatures are starting to increase as well. This is where I'm from. I grew up in North Wales, in Snowdonia. I feel very blessed to have grown up there. I love these mountains. And if you hike up one of them, like this, up to summit of Penarrola Wen, and look out, you can see Ogwen Valley, or the Nant Francon, and the different coombes that it's got going down, the gullies going down the sides of the mountains. Those were formed by glaciers at the height of the last ice age. If you'd been up that hill 20,000 years ago, this is what you'd have seen. You'd have seen the Merioneth ice cap with just the summits of those hills. You've got Trevan there, Glydir, and Lydir Vawr just poking out amongst this sea of ice as little islands. Across the whole of Europe and Scandinavia was a massive ice cap. And then south of France was basically a tundra, and Spain and Italy were coniferous forests like you'd see around Russia today. Basically, the south of France looked like northern Finland does today. How big a change was that between the last ice age and today? So during that period, we can go what we would say was one ice age unit, right? The temperature difference between one ice age ago and today. And that's roughly 4.5 degrees Celsius change on the global scale. So it doesn't sound like a lot, but it's made a huge difference to the whole of the world, okay? That 4.5 degrees. And if we were to go the equivalent change into a warmer planet, that's the question mark. Can everybody hear me okay if I don't stand by the microphone? Okay, sorry, thanks. So if we go 1 unit warmer, 4.5 degrees warmer, what would the world look like? And the answer is we're going to find out in 86 years' time if we don't do something about it, because that's how much we're expected to warm. Okay, here's a video showing the global warming that's happened over the last 120 years or so. It's produced by NASA, and you can see that the temperatures here, blue is cooler than the average of this time series, and red is warmer than the average. And you can see that from year to year, there's natural variability, so some places are warmer than others. But over time, the planet has warmed up, and it's particularly warmed up in the Arctic. It's actually warming roughly twice as much up there, which is why you're seeing really profound changes up there now. So that's why I would say that we're now facing a climate emergency. Sounds alarmist, doesn't it? But I'm not saying that. That's what this man says, Ban Ki-moon, who was the former head of the United Nations. This is an emergency, and for emergency situations, we need emergency action. He's saying that because that's what the scientists are saying. James Hansen, former director of NASA, Goddard Institute for Space Studies, we are in a planetary emergency. Professor John Horton, former co-chair of the Intergovernmental Panel on Climate Change. Climate change is accelerating more rapidly and dangerously than most of us in the scientific community had expected. Lonnie Thompson, professor of Bird Polar Research Center. He's one of these guys who goes out and takes these ice cores that I was telling you about before. Virtually all of us are now convinced that global warming poses a clear and present danger to civilization. So if that's what scientists are saying and thinking, why is that not a message that we hear repeated and reported more often in the media? So this diagram is only a schematic, but I think it helps explain what's going on. The media likes to present both sides. It likes to create a sense of balance. And so we've got here along the bottom the predicted impacts of climate change. Slight benefit, neutral, slight cost, substantial cost, and catastrophe. There are some people who say that there's not going to be much impact of climate change. They're often referred to as climate skeptics or sometimes deniers. On the other side, the media kind of reports in a box between that view and the opposing view, which is seen as people who are saying climate change will cause some or a substantial cost. But the rest of the informed opinion is considered unreasonable and therefore not reported because it doesn't fit within the frame that they use to discuss this, even though that's where I would say the majority of climate scientists sit. So this is the same video that I just showed you, but plotted as a graph. So we've got temperature anomaly, so that's the change in temperature that we've seen against time. And this is going up to the year 2016, and 2016 was the hottest year on record. That was surpassing 2015, which was previously the hottest year on record, which surpassed 2014, which was previously the hottest year on record. If we carry on warming the planet as we are doing, then this is what we're going to see. So again, this is temperature anomaly, temperature change relative to this baseline. And we can see the black line here represents the same temperature time series as I just showed you on the previous slide. And if we carry on burning fossil fuels, we'll go along the red pathway, which is the fossil fuel intensive pathway. And you can see that there is uncertainty around that. And that's because there is uncertainty in the science. We're not entirely sure what the outcome is going to be of doing that. But the uncertainty in that, there's much bigger uncertainty between choosing to do that or choosing to switch to the blue pathway, which would take us to 2 degrees. Putting that red curve in context of the last 10,000 years, this is what it looks like. Now remember, all of civilization has evolved to cope with the stability that this last 10,000 years has provided us. Indeed, some people would say that's the reason that civilization happened when it did. Because you could start predicting when the rains were going to fall. You could predict how much rain you were going to get. You could predict where the sea levels were going to be. You could predict how high the floods would rise. But we're going to go out of that. We're leaving that behind. And it's the extremes that matter. So that was just the average temperature. But what we need to understand is that's the climate. But what happens on a daily basis is weather. And so this plot here shows you how the distribution of extreme temperatures will change as a result of our warming planet. So actually, this shows you the changes that have already taken place. So the way to understand this is that this is the temperature of extremes that you'd expect in a summer in the northern hemisphere in the base period, which is 1950 to 1980. And basically, a third of the time, you'd expect temperatures to be about average. That's the white area. A third of the time, you'd expect the temperatures to be below average, so that's the blue. and a third of the time you'd expect them to be above average, and that's the red. So I'm going to play this, and you can see how this distribution has shifted over time. So this is what it looked like in the 1950s and 60s. This is what it's 70s through 80s, 80s through 90s, and this is going into the 2000s. Okay? So what that means is that these really hot extreme temperatures that we never used to see happen are now happening. And the analysis concluded that this hot extreme, which covered much less than 1% of the Earth's surface, now typically covers 10% of the Earth's land area. And this is only with 1 degree of warming, okay? The Met Office and the Hadley Centre, which do a lot of climate change modelling in the UK, carried out an analysis, and they said, well, what would these extremes look like if we warmed the planet by 4 degrees? Their conclusion was that for a 4-degree mean surface temperature increase, then on the hottest days of the year, the temperature in China would be 6 to 8 degrees hotter than it currently is on the hottest days. In Central Europe, the temperatures would be 8 to 10 degrees hotter than the hottest days that they've currently experienced. And likewise in New York, it would be 10 to 12 degrees hotter. You can just imagine the kind of impact that that has on the infrastructure of a city, on growing crops. So here's what that looks like as a map. Okay, so this is looking for Europe. This is the number of extremely high temperatures. So days where you have nighttime temperatures over 20 or daytime temperatures over 35. So these are temperatures that put lots of stress on a human's body, right? Especially if it goes on for a few days. And what you see is that this is the number of days a year that you'd expect to see that kind of level of temperatures. This is the world as it was from 1960 to 1990. Then it's 2020 to 2050 and 2070 to 2100. And you can see that you start seeing more than 50 days a year in much of southern Europe, such as Spain, Italy, Greece. I mean, these are temperatures reaching these really extreme temperatures more frequently than they currently do in many parts of North Africa. I was in France on holiday in 2003 when one of these extreme heat waves struck. And it was unbearable. I was camping at the time, and you literally could not stay in your tent after the sun rose. We used to spend our days kind of running around between supermarkets to use their air conditioning. I can remember that. But about 15,000 people estimated extra died in France as a result of that. In fact, across the whole of Europe that summer, it's estimated that the number is closer to 70,000 people, excess deaths that summer. This is what that spike looked like. So 2003 was really extreme, nothing like it had been seen before. But by 2040, that's going to be an average summer. And by 2060, most summers will be warmer than that. All right, so that's in our lifetime, that's in our kids' lifetime. You can extend that kind of analysis and do it for the whole world. So this takes the last 150 years, so we can look at that, and when we then say, over that last 150 years, which year was the hottest year on record at that location? And then we can ask the question, at what point in the future will every year be hotter than the hottest it's ever been at that location? So every subsequent year is hotter than the hottest it's ever been. And we can get a date. And this graph then plots that date. So you can see here that in the tropics, we reach that date much sooner. We reach that date in the 2020s to 2030s. So in those areas, every single year is going to be hotter than the hottest year that's ever been experienced at that location. By the 2040s, that's most of the subtropics, and by 2050s, that's kind of the higher latitudes. So that's London, for example, is 2056, and that's because normally we see larger changes in our interannual variability. So some years are very hot, some of them are much cooler. Whereas the tropics, they're much more steady. They have a constant temperature year-round, and from year to year. What does that mean in terms of drought, for example? So this graph here shows you how dry the soils are in different parts of the world. It's known as the Palmer Drought Severity Index. The top graph shows you what it's thought to be for the last first decade of the 21st century, and then what it's predicted to be in 2030 to 39, 2060 to 69, and 2090 to 99. The key thing to understand here is that the color scale, right? So pinks and purples are very, very dry, and blues are wetter. So for reference, this kind of magenta purple was pretty much as bad as it got in the Dust Bowl in the United States. And we can see by about 2060, much of the breadbasket of the United States is experiencing those kind of dry temperatures. Likewise, much of the Mediterranean and the area around Turkey and Ukraine, and also northern Brazil by the later century. All of these areas are becoming very, very, very arid at that point. We know that drought can have a huge impact on crops. So this is a picture from 2012 when a drought struck the United States and wiped out about 30% of their corn harvest across many of their major grain states. This picture here is of California, and it shows you the drought that they've just had over the last 5 years and how it built up from 2011 through to 2015. It just broke this last winter. But this is the worst drought that has ever been recorded in California, and we can use tree ring data to say it's the worst drought that's happened in a much longer period of time than that. This is Yosemite Valley, and shows you how the snowpack kept on decreasing, and it just didn't get replenished at the end of each year. And that's the effect that that had on the reservoirs in California. And you can see just how hot exceptionally hot it was that year. This is 2014-15. It was incredibly hot. And it was also very dry that year. So it was both hot and dry, and it was that combination that led to this extreme drought. So scientists in the US have carried out analysis on this to see how much more likely this was to happen because of climate change. And they concluded that the severe risk of drought in California has already increased due to extremely warm conditions induced by anthropogenic global warming, and that it's only likely to carry on increasing in future. This graph shows you how important California is as a food-producing region of the United States. So for example, just in the Central Valley, you're growing 99% of all almonds, walnuts, pistachios, 95% of broccoli, over 90% of strawberries, grapes, tomatoes, and 74% of all lettuce. It's grown in just that one region of the United States. This is a photo of them scrubbing entire orchards of orange trees because they couldn't afford to water them. So the farmer had to make a decision. It was going to keep that part of the crop, but had to lose the rest. And they just drove them over with bulldozers. So going to the future, what will that look like? Well, if we can switch to a low emission scenario, we have a hope of holding it to this one, where it does carry on drying out. But if we don't and carry on with a high emission scenario, then most of the United States is going to look like a dust bowl, as well as Latin America. We're already seeing droughts like this happening around the world. So this is from Brazil, where Sao Paulo, the largest city in South America, almost had to be evacuated because of a drought crisis. India, 330 million people affected by drought last year. And this was from 2010. There was a heat wave, an extreme heat wave, like the one that happened in France, that struck Russia, and it caused wildfires that burnt through much of their harvest. As much as 40% of their harvest was lost, and they had to declare an export embargo in Russia. That had a consequence, and that was that food prices around the world went skyrocketing. This is a measure of the food price index. It's a measure of food prices around the world. And you can see that there was two spikes, one in 2008 and then another one 2010-11. The one in 2008, most people associate with a switch in policy towards including more grains in biofuels, whereas the one in 2010, people say is related both to the drought and extreme wildfires in Russia, which led to the embargo, and also another drought that happened in China at the same time, so it was the two together. But in both cases, you had this huge price spike, and these red lines show you incidences of food rioting that took place around the world, and the names of different countries. And if I draw your attention to the second spike, you can see names like Tunisia, Libya, Egypt, Yemen, Syria. Now, I'm not saying that the two things are directly related, but Egypt at the time was the world's largest grain importer. It had imported more wheat than any other country. And people's cost of living went through the roof. They couldn't afford to buy bread, so they went out on the streets and they started chanting for bread, freedom, and social justice. And bread was a key priority when people came out in the Arab Spring. We now know that that drought in Russia was about 5 times more likely to have happened because of climate change. This is a picture from Syria. And again, I'm not trying to say that climate change caused the war of Syria or anything as simple as that, but it was a factor. Why do I say that? Well, Syria has been drying out over the last 100 years. And in 2006 to 2007, there was an exceptional drought. It was the worst drought now we know for over 900 years. And this graph shows you that the dark brown areas, there was fewer than 50% of normal rainfall in those areas. 85% of livestock died in much of northern Syria, and farmers were forced to abandon land and head to the cities. About 1.5 million people left the land and moved to Homs and Damascus and other major cities. At the same time, those cities were already stressed by the fact that war in Iraq had caused another million people to leave their homes and move to Syria. And then the price spike hit. And again, people went out on the street asking for assistance, and the government cracked down and repressed its people. So again, I'm not saying climate change caused this, but it was a factor. And we now know that this century-long observed trends in precipitation, temperature, and sea level pressure, supported by climate model results, strongly suggest that anthropogenic forcing has made the occurrence of a 3-year drought as severe as that of the 2007 to 2010 2 to 3 times more likely than by natural variability alone. This is a comment from a cable from the US Embassy that was leaked through WikiLeaks in 2008. And the US Embassy sent a message back saying, Syria's UN Food and Agricultural representative told us that the Syrian Minister of Agriculture stated publicly that economic and social fallout from the drought was beyond our capacity as a country to deal with. This social destruction would lead to political instability. And indeed, that was the case. And 2 years later, the civil war broke out. This is some work done by Oxfam looking at agricultural prices for commodities and how they're expected to increase up to 2030 compared with 2010. The dark green shows the baseline, so how much food price is expected to increase as a result of changing population, changing diets, and so on and so forth. The dashed green line represents the additional increase that climate stresses is going to cause to that price. And you can see, for example, wheat, they're predicting a 120% increase in the cost of wheat by 2030 compared to 2010. And for maize, it's 180% almost. You've got to bear in mind that for many families around the world, they're still struggling and often spending half their income on food. So this is almost doubling the price again. And that doesn't even take into account a price shock like the ones I was just telling you about. So imagine that you had the same drought as you had in the US in 2012. What would that do to the global food prices then in this scenario in 2030? Well, according to Oxfam's research, they said that that price shock would cause an additional 33% increase in wheat prices and additional 140% increases in maize prices. So if you take the maize price, for example, that's now almost 5.5 times more than it currently costs. This map shows regions of the world currently, well, particularly Africa, currently receiving food aid, emergency food aid. It's just released the other day when the UN declared that this is currently the worst humanitarian disaster that we've seen since since the 1940s. The size of the bubble shows you the population in that country that is currently receiving food aid. And in particular, 4 countries are marked out with a red circle, which are Yemen, Somalia, South Sudan, and Nigeria. The UN saying that famine could break out in those countries this year, and they're talking up to 22 million people are at risk. The reason it's so bad is a combination of factors again, it always is, but drought is one of those, another one obviously is war. this is from the UN CCD, the UN Convention to Combat Desertification. It's 3 graphs. The first one shows the countries most vulnerable to desertification in Africa. The second one shows places where there were food riots in 2007 to 2008 when there was that food price spike the first time. And the third one shows you terrorist attacks that happened in 2012. And what they were saying is that there's a connection between these things. It's not always a direct connection, but that the instability, partly from all 3 of those things, feeds off each other. And this graph shows you the 200 millimeter aridity line in red, the red line. So that's kind of right on the cusp of where agriculture is viable in many of these regions. And the red dots show you where the US have been carrying out drone strikes. Okay, so partly as a result of water scarcity, partly as a result of food scarcity, and many other things, the WHO have said that climate change will affect in profoundly adverse ways some of the most fundamental determinants of health. Another one that they stress is the way at which disease will change as vectors migrate around the world. So this is a map of the distribution of Aedes aegypti, a mosquito that carries diseases such as yellow fever, dengue, and Zika virus. Currently, it survives all year round in the areas that are red, and it can survive for some of the year in areas that are blue, but it can't overwinter there and it can't lay its eggs in those areas. Now, as the temperature warms, it's predicted that by 2060 to 2080 in the low emission scenario and in a high emission scenario, that's the 2 graphs, that we're going to see an expansion of the range of this mosquito quite considerably. And so we can see that will lead then to it potentially being able to spread the disease into more areas that it currently can't reach. It's not just temperatures that will be changing, it's also the amount of flooding, wildfires, extreme storms that are happening. And indeed, we're already seeing that that's the case. So this is data from the World Meteorological Organization, the WMO, which shows the number of reported disasters by decade categorized by different hazard types. So we've got floods, storms, droughts, extreme temperatures, wildfires. And you can see that these things are all increasing. And they're increasing in line with our projections. Actually, they're increasing faster. So this is John Holden, who's the former US Presidential Science Advisor, who was also former president of the AAAS, the American Academy for Arts and Sciences. He says, everything that is expected to result from global climate change driven by greenhouse gases is not only happening, but it's happening faster than anybody expected. And we're seeing floods, extreme floods, record floods around the world constantly. This is just from last year, 2016. So we got the UK here, 2015 to 2016, the flooding in Cumbria. We've got Texas, Sri Lanka, France and Paris, Wuhan in China, Louisiana again in the US, North Korea, 100,000 people were displaced by flooding in North Korea, South Africa, Spain. It's happening everywhere. And if we take, for example, the UK example from 2015 to 2016, if we take the whole of December and look at the amount of rainfall that fell in December and compare that to average, some parts of the UK, in Cumbria and North Wales, for example, saw 300% the average rainfall for that region in that month. So where that was for where my parents live in North Wales, that was that was a metre of rain that fell in that month. That's more than we'd normally see in a whole year at that area. And we saw extreme flooding as a result. So this is Dame Professor Julia Slingo. She was former chief scientist at the UK Met Office. She said that all the evidence suggests that there is a link to climate change. There is no evidence to counter the basic premise that a warmer world will lead to more intense daily and hourly rain events. Frederica Otto from the University of Oxford, who carried out an analysis of this, which found that this flooding was about 50 to 75% more likely to have happened because of climate change than it would have if climate change hadn't happened, says that greenhouse gas emissions are loading the weather dice towards these warmer, wetter winters. If we change and cast our eyes up to the Arctic, we see that there are rapid changes going on there as well. So this is the Arctic sea ice, and you can see that what you're getting is ponding on the sea ice as ice is melting. And that ice is much darker than the white ice, and therefore reflects much less energy back into space, and instead it absorbs it. And that causes more warming, and that's part of the reason that we're getting this amplification of warming in the Arctic area. This is the minimum sea ice extent at the end of summer. So the sea ice grows in winter and then shrinks again in summer. This graph at the top shows you what it shrunk to in 1979 when the satellites first started recording this data. This bottom graph shows you the extent of the sea ice in 2012, which is the lowest it's ever got to currently in the summer. You can see all that extra area of blue, which is absorbing heat and warming the planet more. This graph shows you that minimum extent and how it's been declining over time compared to what the models were predicting. And you can see that it's declining much faster than the models were predicting. This is Mark Cerise, who's director of the National Snow and Ice Data Center. He says, we may lose the summer sea ice cover as early as the 2030. This is in itself much earlier than projections from nearly all climate model simulations. We're seeing melting. So when sea ice melts, it doesn't raise sea levels because it's already floating. But when ice on land melts and flows to the sea, that raises sea levels because you're putting more mass into the oceans. And so we're seeing that both Greenland and Antarctica are now losing mass at an accelerating rate. And that's causing sea levels to rise. Nobody expected the ice sheet to lose so much mass so quickly. This is a researcher who works on Greenland. So this is now looking not at the major ice sheets, but at glaciers around the world. So this is a glacier in Alaska in 1941, and the same shot in 2004. This is in Argentina in 1928, same shot in 2004. The ice is gone. This is in the Himalayas, 1921, and I think it's 2009. There are many cities around the world which rely on glaciers to get their water supply. This is La Paz, it's the capital of Bolivia. It's home to about 800,000 people. Its water comes from that mountain in the background, the Illuminati Glacier. So this glacier is rapidly retreating. During the summer, a lot of the water that the city of La Paz relies on comes from that glacier. Same for its sister city, El Alto, which has got about 1 million people. Bolivia is currently in the midst of again, a record-breaking drought and has declared a state of emergency. They've got water rationing going on currently in the city. This is the Indus Valley, so it's Pakistan, and the Indus River gets most of its water from the Himalayan glaciers. Again, those glaciers are now rapidly retreating. At least 4 of the 5 glaciers that feed into the Indus, first of all, run through India and the Kashmir region. And there's lots of disputes over how that water is divided between the two countries. So all of that ice melting from both the glaciers and the ice sheets, and also expansion of the water as it warms itself, is causing sea levels to rise, and again, rising at an exponentially increasing rate. These are the predictions for what sea level rise will look like by 2100. And what they've done here is asked experts for what they think their most likely outcome will be in 2100. And that's this red line here shows you the predicted range by these experts for 2100, and the blue one shows you the same thing, but if we follow a low emission scenario rather than a high emission scenario. You can then compare that as well to what the IPCC have said for those future times. And you can see again, the IPCC's most recent report is conservative when it comes to what the predictions are from the experts when you pull them directly. So what would a 1 meter sea level rise do to a city like New York? So 1 meter sea level rise could raise the frequency of severe flooding for New York City from once per century to once every 3 years. We saw what the effects of that once every century storm looked like when Hurricane Superstorm Sandy struck New York City. This is the flooding in the underground stations. This was one of the districts along the coast. That's one of the piers. It's not just cities, and it's not just New York. It could be Miami, it could be Rotterdam, it could be Bangkok or Shanghai that are at risk. It's whole countries. So this is Bangladesh. And with 1 meter sea level rise, sorry, this green area here are areas with high population density. This 1 meter sea level rise is predicted to displace 15 million people and submerge 17,000 square kilometers of land. With 1.5 meters, you're talking about displacing 19 million people. This is what that looks like on the front lines, where people's homes and livelihoods are being eroded. And the question we've got to ask is, where are these people going to go? Currently, they're going into Dhaka already. But India's building, or already has built, a 10-foot high fence around its entire perimeter border with Bangladesh, and has now got armed guards patrolling it day and night. Okay, this is a different problem to climate change, but it's related because it comes from our same CO2 emissions. So the oceans are absorbing some of that carbon that we're putting out into the atmosphere. It doesn't just stay in the atmosphere. But as it goes into the oceans, it causes them to become more acidic. The CO2 dissociation becomes a weak acid. And that's causing the oceans to acidify, and they're now 30% more acidic than they were at the start of the Industrial Revolution. If we carry on a high emission scenario, they'll be 150% more acidic by 2100. If we switch to a low emission scenario, we might be able to stop this getting worse. But what it does is it removes from solution the bicarbonate ions, or the carbonate ions, that these organisms that make shells, such as mollusks and crustaceans and corals, use to build their shells. And so as it becomes more acidic, it becomes harder and harder for them to build their shells, and they become more frail, more brittle, and eventually they can't do it. This map shows you the areas of the ocean which were suitable for, which had a high concentration of these ions in the past, in the 1860. This is what it looks like now, and this is what it's predicted to look like in the year 2050, and the year 2095 if we follow a higher emission scenario. The thing to realize is that if they're in these red colors here, that's basically when the concentrations are too low for many of these organisms to successfully make their shells. So again, these are the organisms that support the base of the food chain that all the rest of marine life depends upon. Corals are particularly badly hit because not only are they susceptible to this ocean acidification, they're also affected by what's known as coral bleaching. Whereas the temperature goes up and causes heat waves to happen, those heat waves also happen in the sea. And when the temperatures in the sea rise too high, the corals get stressed and they basically bleach. And so the zooxanthellae organisms that are the corals and their symbiosis with the algae that live inside of them breaks down. And so the corals start to starve. If the temperatures cool down quickly enough, then the corals can recover. But if they don't, then eventually they'll die. What this graph shows is the rate of bleaching that we'd expect to see with 1.5 degrees of warming and 2 degrees of warming. And basically, by the time we get to 2 degrees of warming, we're expecting bleaching to happen almost on an annual basis. So even at 2 degrees, corals are going to really struggle. Now, many of the world's fisheries depend on corals. So all around the Philippines, Indonesia, many of those people in the Philippines, for example, 90% of their protein comes from fish that is caught from coral reefs. This is the Great Barrier Reef. There was a mass bleaching event that happened there in 2016. The northern sector, which was the most pristine sector, lost, well, 81% of that was severely bleached, and they lost 60% of their corals as a result. This year, there's another bleaching event currently occurring. It's the first time it's ever happened back to back. This is an Australian scientist who studies corals. He's now saying that he thinks that 20 years from now, every summer will be too hot for corals, and they will disappear as dominant members of tropical reef systems by 2040 to 2050. It's hard to argue it any other way. And this could be said for all different types of organisms, okay? So these red areas are known as biodiversity hotspots. It's where the majority of the world's species exist, whether or not that's plants or animals or fungi. And basically, as you see, that most of those are in the tropics. And as we discussed earlier, the tropics already is going to see temperatures which are exceeding the warmest temperatures that they've ever been in those areas within the 2020s to 2030s. So all of these species are going to have to adapt to those changes. Many of them are going to try and migrate. So all of these impacts will be happening simultaneously, and they'll be getting worse decade after decade. And that's the thing that struggles to kind of convey a little bit, because I have to go through them linearly one at a time, but actually you have to think of this as a systemic problem. But climate change is systemic in the sense that it affects everything. So here's some quotes about climate change, right? So climate change is the biggest human rights issue of the 21st century, says the former UN High Commissioner for Human Rights. It's the greatest environmental threat that humanity has ever faced, says Greenpeace. It is the biggest global health threat of the 20th century, says The Lancet. It presents security challenges of a magnitude and a complexity that we have never seen before, says the former Secretary General of NATO. It is the single greatest threat to sustainable development, says the former UN Secretary General. And it is the greatest market failure that the world has ever seen, says Nicholas Stern, who was chief advisor to the United Kingdom about climate economics. It's all of these things. They're interrelated. So that is why the world has come together to say we have to avoid this, we have to stop this. And this diagram is known as the burning embers diagram. It shows you how risk increases with temperature across different categories. So we've got the risk to unique and threatened ecosystems being really high at even low temperature changes, like coral reefs and so on and so forth. The risk of extreme weather events, the risk of distributed impacts to different parts of the world or aggregate impacts to the world economy as a whole, or the risk of large-scale discontinuities, which sometimes scientists refer to as tipping points. So these are dramatic changes in the way the Earth system functions. Now, the 2 degrees guardrail that Christian mentioned earlier comes from this analysis, right? It says that we can accept some risks, which basically is the North saying we can accept certain degrees of impacts in the south, of the global south. But we can't accept more than that. The risks just become too great. So we have to draw the line, we have to try and hold to that line. As I've been trying to illustrate throughout this talk, the science is getting worse. The predictions are always happening sooner than we'd expected, right? So this analysis was from 2001. It appeared in the 3rd assessment report of the IPCC. They redid the analysis in 2009. That's what it now looks like. Okay? So 2 degrees is what it is, but don't go away with the sense that 2 degrees is safe. So again, this is John Holdren. He was the science advisor to Barack Obama. He says, avoiding dangerous anthropogenic interference in the climate is in fact unattainable because today we are already experiencing dangerous anthropogenic interference. The real question is whether we can still avoid catastrophic anthropogenic interference in climate. So here's the text from the Paris Agreement. I've picked out a part of it which says, the goal of the agreement is to hold temperatures well below 2 degrees Celsius above pre-industrial levels, and to pursue efforts to limit temperature increase to 1.5 degrees Celsius, if possible, and that this agreement will be implemented to reflect equity, and that's really important, and I'll come back to that later on in the talk. Okay. So at that point we go, okay, what do we have to do to meet those commitments? And the UK has got a commitment for 80% reduction in CO2 emissions equivalent by 2050. The EU have a similar pledge to do so by 60 to 80% in the same time period, and the world as a whole has said it will reduce emissions by half by 2050. But CO2 stays in the atmosphere for over 100 years. So long-term targets such as these are in fact, I would say, dangerously misleading. And if I was to put it bluntly, I would say that these 2050 targets are unrelated to climate change. Now, why do I say that? The reason is that you have to try and think of the atmosphere as a bathtub, right? It's a stocks and flows problem that we're dealing with here. So as we're turning on the taps, we're filling up this bathtub. And basically, we're trying to stop the bath from overflowing, right? So we're currently opening and opening and opening the tap, and so more liquids or CO2 is going into the atmosphere, it's building up. This video shows you that process happening, right? So the circle as a whole is our budget. And this is how fast we've been filling that budget up. We've been opening the tap and putting more and more and more water into the bath faster and faster. And it's accelerating, right? If we go over and fill the whole circle, that means we've blown our budget for 2 degrees. So you can see we've now got to really radically reduce our emissions quickly if we're going to stay within this target. I can show that a different way. So this graph shows CO2 emissions on the y-axis, and it's got temperature, date on the bottom axis. So CO2 emissions have currently been going up. They've gone past 30 gigatons a year. And if we were to have peaked emissions in 2011, we could have followed the green line here and reduced emissions and been about 80% or so reduction by 2050, and that would have met our carbon budget. But we didn't. So if we peaked in 2015, we'd now have to come down at a faster rate because we've carried on emitting emissions in the meantime. And so in order to make up for that, we've got to come down sooner and actually be at zero by 2045. If we delay even longer and wait till 2020 to peak emissions, then we've got to come down faster still, right? Because it's the cumulative emissions that matter. It's our budget. So this rewrites the chronology of climate change. It's not a long-term problem with gradual reductions. It's an urgent problem that requires radical reductions that have to happen now. So some people say that's too hard, right? So is aiming for 4 degrees more realistic? Well, for 4 degrees Celsius increase, then again, peaking emissions in 2020, we would have to reduce them at about 3.5% a year, and then we'd end up with a 4 degree C world, right? Now, I, along with many other scientists, say that that's probably beyond adaptation for humanity. So this is Kevin Anderson. He's the former director of the Tyndall Centre. It's one of the leading centres for climate change research in the UK. He says, there is a widespread view that a 4 degrees Celsius future is incompatible with an organised global community. It is likely to be beyond adaptation, is devastating to the majority of ecosystems, and has a high probability of not being stable. Rachel Warren, who's an expert in food, agricultural systems, who works on these issues, has said, we have already observed impacts of climate change on agriculture. We have assessed the amount of climate change that we can adapt to, and there is a lot that we can't adapt to even at 2 degrees Celsius. At 4 degrees Celsius, the impacts are very high, and we cannot adapt to them. Even the World Bank has seen this and agrees, okay? So they wrote a report called Turn Down the Heat, Why a 4 degrees Celsius warmer world must be avoided. They go, there is also no certainty that adaptation to a 4 degrees Celsius world is possible. A 4 degrees Celsius world is likely to be one in which communities, cities and countries would experience severe disruptions, damage and dislocation. With many of these risks spread unequally, it is likely that the poor will suffer the most and the global community could become more fractured and unequal than today. The projected 4 degrees Celsius warming simply must not be allowed to occur. Okay, so if we're talking about adaptation, I think this is the take-home message, okay? The bottom line is that you've got to adapt to what you can't, that won't get mitigated, but you've got to mitigate what you can't adapt to. And mitigate is avoid by cutting emissions. Because at the end of the day, nature does not negotiate. Or as Hans Schellenhuber, who advises both Angela Merkel and the Pope on these issues, has said, political reality must be grounded in physical reality, or it's completely useless. And this is the political reality that we're facing. So this is, again, how much CO2 we've burned, illustrated by the size of the bubble, as being burned from 1850 to 2000. From 2000 to 2010, we still burnt a substantial amount. And then the remainder of the budget that we have left, if we wanted a good chance, that is an 80% chance of avoiding 2 degrees Celsius. And that's given in the other bubble. What the other bubble, the red bubble, shows you is the fossil fuel reserves that are proven and on the books of the oil, gas and coal companies today. So these are the reserves that they're predicting to dig up and mine. They've got them already there. They're in development now. And basically, it means that there's an extra 2,230 gigatons of CO2 available to be burnt that goes beyond our remaining budget. The Bank of England have seen this. They understand that this is a threat to the economy as it is. And they've said that the vast majority of reserves are unburnable if we're to meet our 2 degree C commitments. But the fossil fuel companies don't see it that way. They're continuing to look for more resources and reserves. So this is the tar sands in Canada. Fracking, which they're trying to bring over to the UK now, do around Sheffield even. And even drilling for Arctic, oil in the Arctic now that the sea ice is starting to melt. So they're looking, if you look at the business plans of a company like BP or Exxon, whose former CEO is now Secretary of State in the US, they're predicting to carry on growing in demand well into the 2040s, which would completely blow our carbon budgets. So the question's got to be, why is it that this is their message? Okay, why is it that they're selling that message? And it's the same reason as they've been funding climate denial think tanks for the last 20, 30 years. This is a network of all of these institutions are think tanks in the United States that ExxonMobil have given money to, and then the people around that are basically talking heads who spout climate denial nonsense on the television, who work for these think tanks, right? There's a whole network of dark money that exists to funnel money from these fossil fuel interests into these talking heads to distort the political debate and to make sure nothing happens, and so that they can continue selling this image of everything's going to carry on as normal, business as usual, our business plans are just the same as they've always been, and they're trying to own the future through their narrative. And it's not just fossil fuel companies, it's all different industries. So we've got committed emissions from building new power stations, from building new pipelines, from building refineries or airports or roads or combustion engine factories. They're all premised on the idea that the future is going to be the same as it is today. And that's got to stop. So this is a professor from Oxford University saying, investors putting money into new carbon-emitting infrastructure need to ask hard questions about how long those assets will operate for and assess the risk of future shutdowns and write-offs. For policymakers who think of climate change as a long-term future issue, this should be a wake-up call. Whether we succeed or fail in containing warming to 2 degrees Celsius is determined by what we do now, not in future decades. So every single investment decision that's being made, every single building that's being put up, every single planning decision that's being made about what our towns and cities are going to look like for the next 20, 30, 40 years is impacting our commitment to whether or not we're going to meet this budget or not. This is a quote by Jonathan Rowson, who used to work for the Royal Society of Arts. And I think it's really helpful to think about it. He says, the present that occurs now, that we're living now, is shaped by how an imaginary future was acted upon in the past. So the way that we live now is determined by choices that people made in the past based on how they thought the future was going to look. Risk assessment doesn't just represent the future. In altering behavior in the present, it also changes the future that ultimately elapses. And that's what I'm trying to do in this talk, right? I'm trying to inspire you to go out and change the future, because I'm saying this is what the future will look like if we don't do anything. That's not saying that's what it has to look like. It's saying this is our choice. We have to now choose to do something different. And that's also what the fossil fuel industry is doing. They're trying to shape a picture, an imaginary, a framework that says the future is going to be the same as it was. Of course it is. We've got everything being built to be that way. And if we go along with them, we know where that's going to lead. I've just shown you where that's going to lead. We've got to start breaking that mindset and saying, no, you're heading down the wrong path. So what solutions are there? Well, I think we've got all the technology that we need to solve this problem already, right? Whether or not that's wind farms or solar panels, or whether or not it's nuclear power stations or carbon capture and storage. I'm being agnostic on those. But the fact is, these things exist and they are coming down in price hugely for especially things like solar panels, right? This is actually a log-log plot. So this is actually a hugely exponential decrease in the cost and of production of solar panels, right? So it's fallen by, the cost of producing that has fallen by 80% since 2008. This was, I think, just a couple of years ago. The same is true for lithium-ion batteries. Again, another huge decrease in the cost. Wind turbine prices have fallen by 29% since 2008, and this was in 2012. The costs keep dropping. The technology exists, it's there, and it's affordable. And basically, all the energy models just can't keep up with the rate of change. In the same way as I was saying about climate scientists always being slightly conservative and always getting it slightly wrong about how fast climate's changing, the same is true for the energy models trying to keep up with the rate of change in the energy system. So this is showing you the rate of increase in the installed capacity of solar and of wind. And the coloured lines show you predictions that were made in the World Energy Outlook, which is a report released by the International Energy Agency every year. And you can see every single year they've underestimated the rate of deployment by a considerable amount. So we can do this. The technologies exist. We're already deploying them at a record rate. But time is of the essence, okay? These carbon budgets are really tight. And basically there's not enough time to build all of that stuff. We have to reduce energy demand in the short term so as that we have time to build the energy supply that will take us to this low carbon, carbon neutral future that we need to get to. And I think there's huge opportunities for saving by reducing demand, because you're not only just saving the energy that you're not using, you're saving every bit of energy that's upstream to get us there. And so if we take, for example, 10 units of light from one of these light bulbs, there is an inefficiency in the way that the light bulb works. It gives out a lot of heat. It doesn't just generate light. That energy also then had to be transported to that light bulb through cables, which are inefficient, and there's resistance in those cables, which causes more energy to be lost. And those cables come from a power station, which burns coal or gas, which is inefficient. And therefore, a coal power station you only use 40% of the energy that you put into it. The other is lost as heat. And then likewise, you've actually got to ship and mine coal to get to the power station in the first place, which is another inefficiency. So for every 10 units of light that you save, you've actually saved 133 units in terms of the overall energy that took to generate those 10 units in the first place. So by not using energy, we actually make a huge reduction in the amount of energy that needs to be produced. The electricity system demand-side opportunities dwarf those from supply in the short term, and that's really, really useful. But we can't use these savings to growth, and that's typically what's happened in the past. We've constantly been becoming more efficient at using energy, but we then just spend it doing more things, buying more things, and having more lights. And we've got to not do that if we're to make this work. And the other thing that we have to do is that we have to think of the whole system as joined up together. So you have fossil fuel extraction on the one hand, then you have the combustion and the infrastructure that's used, and then you have the consumption, right? So if we're trying to reduce the consumption as much as possible, then it doesn't make sense to continue investing in infrastructure that is used for combustion and investing in extraction, like the current government is doing. They're just giving new tax breaks to the fossil fuel industry in the North Sea to get them to increase production rates. We can't do both simultaneously. You can't increase the supply at the same time as trying to reduce the demand. It just doesn't work. So we can't minimize the consumption of fuels whilst also maximizing supply. The other key point, and again, I think this has a message of hope in the same way as reducing demand does, is about equity. Now, around the world, there's hugely unequal usage of energy. So this is a plot from David Mackay's book, Sustainable Energy Without Hot Air, in which he looks at different rates of CO2 emissions from different countries. And you can see that some countries have really high CO2 emissions relative to others. That's the only message I want you to take away from that. But this graph from analysis done by Oxfam shows us that if we take just the richest 10% of the world's population, they're responsible for half the world's emissions. And vice versa to that, the poorest 50% of the world's population are only responsible for less than 10% of the world's emissions. The inequality is that stark. So this problem doesn't need all 7 billion people in the world to act to solve it. It needs the richest 10% of the world's population to get acting to solve this. And it's the same within the UK as well. So this is a plot from the work in the University of Leeds, which looks at CO2 equivalent emissions in the UK by income bracket. So on the left-hand side, we've got the poorest 5% of the UK population, and on the right-hand side, we've got the wealthiest 5% of the population. And you can see, again, there's a huge inequality in how energy is used and the CO2 emissions that result from that. So it's not everybody that has to act on this problem. It's us. It's the people in this room, right? And that's, I think, an inspiring message, because not only does that then land, obviously, a lot of responsibility on ourselves, but it also gives us agency to solve this problem. We can be part of the solution to this problem. So how to make progress? So often people will say that there's lots of barriers to dealing with this problem. They'll say, for example, that scientists haven't warned us clearly enough. Well, hopefully that's not true, and I'm trying to make sure that that's not true tonight. They'll say that our electoral system is too short-term, or that we don't have the technological alternatives. Again, I don't believe that's the case. I've tried to show you why that's not the case. Our economy doesn't properly cost harm. We're too lazy to change our habits. International treaties have no legal enforcement. Our culture encourages consumerism. All of these are being put forward as reasons why we're not going to solve this problem, why it's too hard to deal with. And climate change is a complex problem. It's often referred to as a wicked problem because there are so many interacting parts that all have to be addressed. But we can flip that on its head, right? That means that all of these are potential avenues and opportunities for tackling this problem. Everybody has a role that they can play, whether or not they're interested in science or culture or technology or behavior or the law or democracy or the economy. You all can do something about this because we need everybody. And there's a report called The 7 Dimensions of Climate Change, written by Jonathan Rowson from the RSA, who I mentioned earlier, and the Climate Outreach Information Network, which looks at each of these and says, well, if they're all important, what can we do in those different categories? And I'm just going to pick out some things that spring to mind, right? So here's an example of a protest that took place in the Tate Gallery, protesting the fact that the gallery is sponsored by BP. Here's Leonardo DiCaprio taking his Oscar award and talking about climate change when he's on the stand. Here's a book by Barbara Kingsolver about the impacts of climate change. It's a great book as well. Technology, right? Here's people building and deploying and researching solar panels. Here's people designing and implementing new architectural buildings that are passive house designs that don't require any energy or light to heat. Here's a gentleman who's, a real technological technophile installing a Tesla battery on his wall in South Wales. Right? There's all things that we can do. Behavior. There's the individual changes that we can make in terms of fixing our light bulbs and choosing what we buy and where we go to travel and all of those things. But then there's also social things, like the municipalities choosing to put in the right infrastructure to help us get around without putting out emissions, such as the Boris Bike scheme in London, or otherwise larger scale behaviour change, like the Transition Network, who are looking at how we can reshape our communities to deal with these problems. The law. So first one is from the Netherlands, where citizens in the Netherlands sued their government for failing to have strong enough climate targets, and they won. And now the government's got to reevaluate its plans and implement stronger targets. We've got Client Earth, who have recently sued and won against the UK government so that they have to clean up air pollution in the UK. We've got here a group of young people, 10 to 18 years old in the United States, who are suing their government to try and get them to take stronger action on climate change. There's things that we can do. We've got democracy. Whether or not that's choosing to vote for politicians who actually mean to take action on climate change, or it's getting involved in making mass protests and making your voice heard and showing that there's demand for change on these issues, or lobbying politicians to implement laws to deal with this, such as the Climate Change Act in 2008, which was world leading and has inspired many other countries to implement similar laws as well. There's the economy. There's the divestment movement, which an example was People and Planet's campaign here on campus, which successfully got the university to stop investing in fossil fuel companies and instead invest in other companies, renewable energy companies. The university now invests almost £1 million in 2 major solar companies. You've got local community solar projects where people have come together, invested their money in renewable energy, and not only does that have obviously a benefit for the climate, but it also brings back investment into the local communities. And you've got as well a list of major multinationals who've signed up to the 2 degrees Paris pledge, and they've said that they're going to support governments to achieve that goal. And then you've got scientists who obviously have to keep releasing their science, doing their science, producing their reports. But they're more than scientists. And this scheme, More Than Scientists, allows scientists to put up videos of themselves explaining their hopes and fears for the future and what they're doing to try and bring about change on these issues. And you've got here a photo of James Hansen, who I mentioned right at the beginning as former director of NASA, Goddard Institute for Space Studies, and a climate scientist himself, being arrested outside of the White House trying to stop fossil fuel projects being built. Now, I think many people find it hard sometimes when you're in the midst of one of these transitions to see that the future can be different. I love this quote because it comes from an English tourist in Edinburgh in 1725 to 26. And he was commenting on the fact that they basically at night time just tipped all their chamber pots out into the street. And the stink in the city was unbelievable. That's why Edinburgh is known colloquially as the Old Reekie. But he wrote that anything so expensive as a conveyance down from the uttermost floor could never have been agreed upon, nor could there be made within the building any receiver suitable to such numbers of people, by which he means a toilet. But here's a photo of Edinburgh with all the sewage pipes running down the side of the building, taking away their waste. This was a massive infrastructure project that took place in cities around the world as a result of trying to make our planet a better place to live. And you can see again, London, this is Fleet Street, digging up in the Victorian times, the entire street really, really deep in order to lay and build all these sewage tunnels. Right? These are substantial changes that were made in order to deal with these problems, and we can do the same. And change can happen really quickly. Okay, so this is a photo from 1900, of Main Street in New York City on Easter Day Parade, and you can see all of these carriages are horse-drawn carriages. Just 13 years later, 1913, there's only one horse-drawn carriage in that photo. The rest are all motor cars. Now, if we look outside and we see combustion engine vehicles going up and down our streets at the moment, we could equally return there in 13 years' time from now and see them all electric buses and cars and bicycles. Here's another great example. Samuel Volcane was chair of Baldwin Locomotive Works, one of the largest steam locomotive companies in the United States. In 1930, he gave a speech on Wall Street in which he said, "It is my judgment that we are just beginning to realize what can actually be done with the steam engine in the way of continuous performance, economical performance, and reduction in maintenance that will continue it in service so that, that it can be more ably discussed in the year 1980 than it will be at this convention in 1930. Baldwin Locomotives stopped producing steam engines in the 1950s and went out of business in the 1970s. He didn't even make it to 1980. And part of the reason that he was forced to make that speech at the time was because the same year, Ford and General Motors were launched on the Dow Jones. He just couldn't see it coming. And here's a quote from Peabody Energy, one of the world's largest coal producers. They released a report in 2010 which said, coal's best days are ahead. This is a graph of their share price. They went bankrupt in 2015. This change is happening really quickly, but it's being resisted. Okay? There are a huge number of incumbents and vested interests who are doing everything they can to stop this change from happening. And we have to fight back and resist against them. And so here's an example of Ben van Beurden, CEO of Shell, just said this just the other week. If we are not careful, broader public support for the sector will wane. This is the biggest challenge that we have at the moment as a company. The fact that societal acceptance of the energy system as we have it is just disappearing. Well, good, that's fantastic. But it's terrifying to me that he sees this as a problem. So we cannot create what we can't imagine. We have to imagine a different world. And the people in these companies and many of the institutions that we currently have are just not seeing the world in a different way to the one that is business as usual. And they have to start seeing it a different way. We have to show them how it can be different. That is our task. That's our life. And there's lots we can do locally even, right? So this is a report from the University of Leeds. It's called the Mini Stern Review. And it looks at Sheffield City region in particular, and it says, within the Sheffield City region, there is a very considerable potential to reduce energy use and carbon footprints through cost-effective and neutral investments on commercial terms. And they actually show that we could reduce emissions by 40%. Here's a graph of them doing that through different measures. And we could reduce emissions by 40%, and that would be at no net cost, and it would pay for itself within 8 years. And that would also return more savings to the local economy as well. So why aren't we doing that? Why aren't we putting pressure on our politicians to do that? Here's a report from the University of Sheffield that just came out the other week. Well, it's in partnership with some other organisations, including the University of Hallam, Sheffield Hallam. But not once in that entire report, which is setting out a plan for the next 25 years for the Sheffield City region, do they mention the words climate change, decarbonisation, or anything of the sort. Why not? You know, how can it be that a report outlining what the city could look like for the next 25 years isn't even touching on these subjects? We can't let that happen. We have to raise our voices. Here's a report for this university in terms of its current carbon emissions reductions. Right? So this top graph here, the blue line shows you what we're doing and what we're projected to be at by 2020. and the red line is what we need to do. Again, as a university, we are failing to even meet our commitments, which aren't even strong enough to hold to 2 degrees. Where are we? We have to raise our voices and make ourselves heard on this, and that is what Carbon Neutral University exists to do. So this whole talk, I know it can be a bit depressing. People have said that to me, but this is how I look at it, okay? This is not a message of futility, but it's a wake-up call of where our rose-tinted spectacles have brought us. Real hope, if it is to arise at all, will do so from a bare assessment of the scale of the challenge that we now face. We have to look at this problem as the challenge of our lives, and we have to act as though this is a planetary emergency, because it's on that scale. So, on a scale of 1 to 5, how concerned would you say you were about climate change? 1, not bothered. 2, mildly concerned. 3, concerned. 4, very concerned. Or 5, alarmed. Yeah. Well, seeing as that you're all alarmed, here's some things I can suggest that you might try and do. So 1 is inform yourself. You're already doing that. You're here at this lecture, but there's lots of great resources and books outlining both the problem and its solutions out there to help you communicate this with other people. Obviously, reducing your own carbon footprint is important, whether or not that's changing your diet, changing your energy usage, changing how you travel. That all helps. But don't get hung up on this. It's far more important that you increase your political footprint. Come together, join either campaign groups, join a political party, join a community, and try and make change happen together. Because it's only through putting our voices together that we'll be loud enough to stand up to the fossil fuel interests at this point. And although we know where the future is going to be and the future is going to be green, the timescale matters, and we have to make this transition as quickly as possible. So thank you very much for your time. The last 3 things is, if you go about your life, try and remember these 3 things. Try and, wherever you can, power down the amount of energy you use, reduce, reuse, recycle, power up low carbon energy supplies, and keep it in the ground. Prevent fossil fuel extraction. And if you make all your important life decisions about which jobs you go into and all of those things based around these 3 questions, then we perhaps have a chance of fixing this. Thank you.